What's up everyone, Patrick here, welcome back, and in this video what we're going to do is find the distance between the two respective points in each of these four scenarios here. So to do a quick little recap, if you remember the distance between 2 points, so if we have like x1, y1, and then we got x2, y2, basically the distance between these 2 points in general is going to be what? The square root of x2 minus x1 to the power 2 plus y2 minus y1 to the power of 2, like that. Right? It doesn't matter which order you put them in. You could put x1 minus x2. You could put y1 minus y2 as well, because you're going to square it. So any negative value is going to turn into a positive anyway. But usually this is how the formula is given. x2 minus x1 squared plus y2 minus y1 squared, and then you got to square root all of that. Now, if you're curious, the way this formula comes about is, I'll show you quickly visually. If we got x1, y1 like this, and then we have another point, let's call it x2, y2. How do we come up with this formula when we're finding the distance between this point and this point? Just pretend this is on a Cartesian plane somewhere. Well, what we can do is we can actually create an imaginary right angle triangle like that, where this is going to be the 90 degrees. Right? So we create a horizontal line and then a vertical line down from this point, and then where they meet there is going to be the corner of that right angle triangle. And then notice that if we create another side here, that's going to be the hypotenuse, and that's actually going to be the distance between these 2 points. Now notice we can get expressions for this length. What's this length here going to be? Well, this horizontal length is going to be the difference between the x values. It's just going to be x2 minus x1. And then the distance between these two, this corner and this point, is going to be the distance between the y values. So it's just going to be y2 minus y1. Right? Because this point has the same y value as this point, because it's on that same horizontal line. So then this side here is going to be y2 minus y1, the difference between the y values. And so we have an expression for this side, an expression for this side, and then this hypotenuse here, we just let it be distance. So if we put this in the Pythagoras theorem, because it's a right angle triangle, we'll have distance to the power 2 equals x2 minus x1 to the power 2 plus y2 minus y1 to the power 2. But we want to get this distance by itself, so we would square root both sides to get rid of that squared here. And so we end up getting that formula right there. So that's how the formula comes about. It comes about making a right angle triangle with those 2 points right there. Right, so basically what we got to do is take each of these points. It's basically algebra. We have to plug it in to the formula. So let's make this x1, y1. This would be x2, y2. And so if we plug everything in, we'll have x2 minus x1, so we'll have negative 3 minus 2 squared plus negative 2 minus 5 squared, and that's going to be all square rooted. So this would end up being the square root of negative 5 to the power 2 is 25, plus negative 7 to the power 2 gives us 49. Right? And I want to make a note that it doesn't matter which way you did it. So if we put the 2 in front, we would have 2 minus negative 3, which would give us positive 5, and then 5 to the power 2 still gives us 25. That's why I was saying it doesn't matter which order it's in. Right? And then from here, we would have what? The square root of 74, like that. And then what you want to do is you want to see if this is going to simplify, but I do not believe this would simplify into anything. It doesn't divide by 4 smoothly. It doesn't divide by 9. It doesn't divide by 16. Right? So I'm thinking about all of the squareable numbers. So square root of 74 is the final answer for number 1. That's the distance between those 2 points. Now here we got 0 and 1, and then -5 and 0. So if we plug everything in here, we would have 0 minus -5, and then we would have 1 minus 0, right? x2 minus x1, y2 minus y1. And this would end up being square root of 25 plus 1, square root of 26, like that. That's the answer for number 2. All right, and then number 3, we got 5 and 3, and then 5 and 6. Now, this one, it's actually easy to think of visually because notice that 5 and 3, that's going to be like here, and 5 and 6, that's going to be like here. They have the same x value. So it's really the distance between them, we could tell visually, the distance is just going to be 3. Right? But if you wanted to plug it into the formula, you'd end up having 5 minus 5, which is 0. When you subtract the x values, then you'd have 6 minus 3, which is 3. 3 to the power of 2 is 9. 9 plus 0 is 9. Square root of 9 is 3. Right? So even if you plug it into the formula, you get the same thing. But whenever I see the same x value or the same y value, like over here, I like to just visually think about it. It's a lot easier. So over here, we got 4 and -2. So -2 is over here. So 4 and -2 would be here. 5, or a -5 and -2. -5 is like over here. What's the distance between -5 and 4? It's just 9. Right? And if you take these points and plug them into the formula, you would get 9 as well. You'd end up getting the square root of 9 squared, square root of 81. And then the y bracket here would be 0. -2 minus -2 is like -2 plus 2, which would give you 0. All right, so those are the answers. Square root of 74, square root of 26, 3, and 9.